Okay, Summer, the first one that's on here, the very first one on the test, wants you to find the circumference of this circle. It's circle R, it's got an R in here, right, like there. It says find the circumference of the circle. This is the only type of information that you get. In order to find the circumference of a circle, just like the one I just did for Spencer, you need let's see, 2 pi r. You need the formula in your head first. And then you start to write things down and you get 2 pi and you don't know what that is. So you start looking around in the circle and you go, I don't know how I'm going to find that, except for the thing that you do know is another formula. You know the arc length, which is m pi r over 180. And you put in there what you can. That would be that the length is actually 4.76. The measure of the angle is 45. R we don't know, over 180. But in this case right here, using this length of an arc thing, I can find R, cross multiply, I get 180 times 4.76. And that's equal to 45 pi R. Then I divide by 45 pi. Don't forget the parentheses on this. I'm just warning you and warning you and warning you. Every time it shows up, I'll warn you again. You have to have parentheses on this when you calculate. Otherwise, it will only divide by 45 and then multiply that result by pi. And that is not what you want. And if you actually calculate this and do it right, that will tell you what R is. So whatever calculator you've been using and you're familiar with, we take 180 times 4.76 and divide that by parenthesis 45 pi. And we get a radius of 6.06, which goes right here. Take that times 2 and then times pi. And we get 38.08 for the circumference, which is what we were asked to find. Since that's in inches, the answer is in inches because circumference is a linear thing. Questions or repeats? Any problems with this? Any questions or things with this? Okay. Next one says, find the arc length. Gives you a circle like this. This is number 2. Find the arc length, and the information you get is something like this. Tell you that's 70, for example, and that this is 10. Find the arc length, you just jump to it. Arc length is m pi r over 180, and they gave you everything you need. M is 70, that's the measure of the arc. Pi, r is 10 over 180. Calculate. Done. Everything you need is there to do this question. Except for the formula. You got to have that in your head, remember. So you might want to have somebody drill you tonight, like spelling words, and make sure you know all the formulas and how they're put together. Unless you want a cheat sheet, which will cost you 10 points. For you, Summer, that didn't know that, you can have a cheat sheet that has only formulas on, no worked out problems. You can have that, but it'll cost you 10 points right off the top of your test. So that if you scored an 87, you'd really get a 77. But that's an option for you. Okay, number 3 is like this. Gives you a circle, gives you kind of a fat angle like that. This is supposed to be the center. Just go with me on my drawing. They tell you what this is. Let's say it's 23 centimeters. And they give you the length of the radius. Let's say that it is 4.28 centimeters. And the question is, how big is arc? And what's the measure of arc XY? That's this one, not this one, this one. There's only 2 letters, it's the smaller one. Okay, so looks like we've got arc length again. So we have L equals m pi r over 180, and we put in what we can. We know L is 23. We don't know what m is, that's what they asked us to find, and we know that r is 4.28 over 180. Cross multiply. 23 times 180. Divided by, well, that'll take care of this, 23 times 180. Then you got to divide by 4.28 pi. And that will leave you with m. Does everybody follow the algebra? Yep. Okay, then you calculate. I didn't do the calculation on here. I assume that you can put this in your calculator. Maybe check with your neighbor and make sure you're getting the same thing they did. Make sure you know what you're doing. By the way, this one was 12.22. I don't remember the units. I didn't put any units on, so that's what it is. This one is 23 times 180 divided by parenthesis 4.28 pi. Don't forget your parenthesis in your denominator, 307.9. That can't be right. I think I made this up by gut. Yeah. Did you get 307 point? Okay, well, that's because I made it up. That's really crappy. It's not this arc. It would be that one. But I'm telling you, if they want the arc XY, it'll be designed much better than I did. They won't make that a 23 compared to that like I did. This should have been more like 14. That was my fault because I just made it up. But this is what you get if you actually did the calculation. So if you've done everything right, that's what M is, even though it doesn't make any sense in the picture. Still, the process is the same. And the number will be designed better than I did. Everybody good? Because I'm going to keep moving on unless you ask a question or ask me to slow down or stop, because I got a lot to do here. Okay, number 10 through 15 all involve squares and or circles. And what it is in every case is an area where some of it has been cut away. And you've got to figure out what's left. And I'm not going to give you all the details like I just did on these. I'm going to give you some samples that require the same skills. So the first one, number 10, says find the area of the shaded region. So in every case, there will be a piece that's shaded. And if I have one like this, and this is shaded, find the area of that shaded region. And this is the type of information they will give you. They'll put a...
Which numbers are these?
This is number 10. I know. I understand. I understand your mistake now. I'm not mistake, but your question. I cut and pasted this off of several tests. So I lost the ones from 4 to 9. I just cut them out of the test. I will tell you this, the answers over on the side where you put your answers do correspond to the numbers. So you're not going to try to put that together, but it goes 1, 2, 3, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So they're all there except for 4 through 9 got cut out, but it goes from 1 to 3 on the answer column and then from 10 to 22. So that's why I said number 10. I see the error now. I see my mistake. Okay, yeah. We just cut it out, but things correspond with what's left, okay?
Yeah.
So this is actually number 10. It's really number 4. I mean, it's the 4th problem you're going to have to do. I understand. I thought I was going to yell at you going, keep up, man. But it's my fault. It's my fault. This is number 10. Okay. Give this arc measure. Let's say that it is, what's that look like? 70 degrees. And the radius length is 2.7 inches. And you are to find the area of the shaded region. You can either do it directly, or you could find the area of the entire circle and subtract the area of that sector. You want to do that? Or do you want to, because we could find the measure of this arc right here, it would be 290, and you could do it directly. Or you could say the entire area of the circle minus this sector whose measure is 70. We could do that. That's kind of what the rest of these are going to require, so that's how I'm going to do it. I'm going to say that the area that we want is going to be the area of a circle minus the area of a sector. Now, you guys, if you follow this strategy that I've been trying to teach you all this time, follow it, write down in general what you intend to do with the areas on these kinds of problems. And then you write this down. Let's see, that would be m over 360 pi r squared. If you can write that much down, this and this, that's half the points right there. You can write that down correctly. And if you can do the plugging in and find the answer, that's the other half the points for the problem. If you just give me an answer and there's all this crap, it's amazing to me how you guys turn in your scratch papers and you expect me to hunt down where your problem is. I'm not doing it, first of all. And if I see it and all I see is a bunch of garbage and I can't tell what you're doing, I'm not going to spend time and effort figuring it out. I've given you a strategy that works every time. And if you follow it, the more lines you get right, the more points you get. What?
So if you don't do like the pi r squared, like with the r and stuff, what if you just put it like with the numbers? Just put the numbers in instead of putting like r squared and m over 360.
Maybe if they're clearly on the picture correctly, but I would really like to see that you know the formulas and you know the strategy. This is a whole circle minus a sector. These are the areas for those things. It'd be a lot better for me to be able to dole out points if you follow this strategy. Besides that, it'll lead you to the answer easier than any other thing I've ever taught as far as these go. So then I look around, I see what I've got. I've got pi, and then I do have an r. It's 2.7 squared minus m. I have that. That's 70 over 360 pi times, and I've got r. It's 2.7 squared. Get this far, you get all but 1 point. If you cannot calculate this accurately, it'll cost you a point. If you can calculate it properly, then you get the whole thing. Where's my calculator? Oh, it's over here on the step. Okay. So now I'm going to calculate it and see if you get the same answer I do. That'll give you confidence in your calculating. I'm not going to come around and tutor each of you on calculations. So we do pi, parenthesis, 2.7, close it, squared, minus 70 divided by 360, pi, parenthesis, 2.7, close it, squared. I get 18.45. You getting that?
Yeah.
So you write 18.45 inches squared, and you don't have to write this on your scratch work. You can just take the answer you get and put it in the blank. But if you've got that leads to that. If you miss this, I'm going to be looking for this to see if I can give you any points. Next problem is something like this. Well, sorry. This problem would be one of the problems that you have, and the next problem will be where this is white and this is shaded. I'm not going to do that problem for you. They both require the same kind of skills. Okay, this one is just the direct application of this. This one was I decided to cut out the middle part. Anyway, the next one has it has a couple of, oh boy, that's crappy. A couple of diameters. It's supposed to be diameter. Like this. And it wants to know, I'm not going to give you all the details. Let's say that it wanted to know what this shaded area is. And this is the information they give you, something like this, that this arc right here is, yeah, I'll give you this one instead. This angle right here is 28 degrees. And the radius of this circle is 6. We want to find the shaded region. My recommendation is that you find one of them and then double it. So your strategy would look like this. 2 times the area of a sector, which would be 2 times m over 360 pi r squared. You see how that keeps track of everything? We're only finding the area of one sector. That 2 out there is going to double it for us, but when we're done. So we start filling in gaps, and I get 2 parentheses, m is 28 over 360, pi, r is 6. Done. Start out with a decent strategy. What are you trying to find the area of? The area of 2 identical sectors. That's what you're doing. So here's the formula of a sector, and these are the details from the picture. It's all there. That'll get you all but 1 point if you can get to there.
This is number 12, right?
Yes. Yes, this is number 12 because number 11 is like unto that one.
Yeah. Okay. Cool.
So 2 parentheses 28 divided by 360 pi parentheses 6, close it, squared, close it. 17.6. Is that what you're getting? Are y'all calculating with me to make sure you... I get 17.6. See if I'm right. And it's inches squared because it's area. Is that what you're getting?
Yes.
Okay. Moving on. The next one, I will give you most of the details on this one. All it is a square with an inscribed circle. That means the circle touches the center of each side of the square like that. And you are to find the leftover stuff after cutting it out of a piece of paper. This is the area this is the information you will get. That's it. You should be able to run with it from there. The strategy is area of a square minus area of a circle. That'll leave you the shaded stuff, right? Area of a square is side squared. It's just the length times the width, but they have to be the same thing. So I write s squared minus the area of a circle, pi r squared. So we start to fill in the gaps here. I don't know exactly what those sides are yet, but I do know this, that pi times 7 squared goes here. How long are the sides of this thing? 14. Can you all see why it's 14?
Yes.
You stretch a diameter across the same as the length of the sides. So it's going to be, I just have to know some of these things. It's going to be 196 because that's 14 squared minus 49 pi. We calculate. You don't have to have this step. Just calculate from the previous one. That's fine. And I get 42.06. Again, in square units. This one's centimeters squared. Yes.
If we're doing notes, are we allowed to draw pictures like this, but no numbers and stuff?
Yeah, no workout problems. You can't show me how you're gonna solve that. But you can have a picture of it and down to the formulas. That's it. Anything else, anyone? Okay. Actually, I lied. All you can have is formulas. You can have formulas for circles and squares and pentagons and everything else like that. You'll have to figure out how to use them on the test. Okay, so that was number 13. 14 is a problem that wants you to solve, that wants you to find the area of it's the area of the crust, I suppose, on a piece of pizza. It's like this. Oh boy, that's crappy, but I'm gonna go with it. We'll pretend that's a really crummy pizza made by a new Domino's expert. Something like this, and your job is to find this area here. And the information that you get is like this. They'll give you this central angle. We'll say that's 60. They'll give you this. That's the radius. And you are to find this shaded area here. And the strategy is that it is the area of a sector. You don't even need the area of a circle, but the area of a sector minus the area of a triangle. Wouldn't that leave us that?
Yeah.
So we fill in the gaps. We got the area of a sector is m over 360 times pi r squared minus the area of a triangle, which is 1/2 base times height most of the time. Sometimes we have other ways of finding area, but we're going to go with this one. So I start filling things in. I have 60 over 360 pi. R is 7 squared minus 1/2. I don't have anything I need for my triangle except for this 60 right here. Well, and this 7. So what I'm going to do in order to get a base and a height is I'm going to drop an altitude. That right there will be my height if I can find it. And in dropping that altitude, I've done 3 things to this triangle. I know it's isosceles because all radiuses are the same, right? I know it's an isosceles triangle. And when you drop an altitude like that in an isosceles triangle, it's perpendicular to the side it hits, it bisects the side it hits, and it bisects the angle it came from. So these are 30. Now, if you can't remember your 30, 60, 90 right triangle stuff, then you can use trig on this. We want to find h. And we also want to find this right here and double it. That will be the base. Would you agree? I need the base and the height. I gotta have to put something in this parenthesis and something in this parenthesis. I'm missing them both. So I'm going after this triangle now. I'm trying to think it through. So if that's 30, and you do remember your 30, 60, 90 right triangle stuff, then this right here, that x right there is going to be 3.5. Because the hypotenuse cut in half is the short leg. And so this whole thing right here is actually 7. Because it's twice as long as that. So this is 7, this is 7. This right here, the height will be this 3.5 times the square root of 3, if you remember your 30, 60, 90 stuff. So I'm going to put 7 in for my base and 3.5 for 3 for the height. If you don't remember those things, and all you know is that you got to find that x and that h in order to find a base and a height, you could do this. You could say, to find the x, you could say the sine of 30 equals x over 7. So 7 sine 30 would be x. But the base of the triangle is 2 of those x's, so it actually be 14 sine 30 that goes here. You could find the height by saying the cosine of 30 is equal to h, the adjacent side, over the hypotenuse, 7. And cross multiply, you get 7 cosine 30, which you could put in right there. Would be this exact same numbers, I promise. So you can either remember your 30, 60, 90 stuff in this case. I'm not telling you this is 60 degrees on the actual. It might be 90. It might be 70. And if it's 70, then when you cut it in half, you're going to have to use trig because we don't have a 35, 55 triangle. So you're going to have to be clever here. If you want to use the trig every time, this is the way you do it. You put the values that you get in here, and then we grab a calculator and see if we can manage to handle the calculator. This is quite a bit of calculating here. 60 divided by 360 pi, parenthesis, 7 close it squared. I'm going to hit enter there. That's 25.656. Then I'm going to do that one. 0.5 times 7 times 3.5 square roots of 3. Oops. That, get out. Oh, come on. Delete that. Get out of there. Close that. And I get 21.217 for this. So I'll take that minus that. And I end up with 4.49. And it will be in square inches. This is a tough one. A lot of people miss this one because they can't keep track of everything. Yes?
Is it okay if you put the exponent in with the number, so like 7?
Yes, if it's just 7 squared. If you've got something like this and you want to square the whole thing, then you want to use it on the outside. So inside or outside, if it's a single thing, it's okay. If it's more than one that you're multiplying together, you want to put it on the outside. Okay, so I get about 4.5 for the area of that piece of crust. This is the process. It's lengthy, it's hard, and it's worth a lot because it's hard. There you go. Next one's pretty simple. If you think about it, and my drawing is going to be really crappy, so just hang in there with me. It looks like this. The drawing looks like this. Actually, it's not too bad. And you are to find this region in here. And this is the information you will get, something like this. It will tell you that this is 8 centimeters. And that's all you get. Oh, no. Yeah, that's all you. Well, they do give you one other thing. It's kind of stupid that they do it. But they give you a thing up here, and they say this is 4 centimeters. They don't need to give you that. But they do. So I'm giving you all those things that they give you on the test. And it looks to me like if you think really carefully, even though this drawing's kind of crappy, what this is the area of a square minus the area of a circle. Right?
Yeah.
Because all 4 pieces of the white, if you could cut them out and lay them down, you'd get a circle. They're all there. Do you understand this?
Yeah.
So this is seeing it more than anything else. So it's going to be s squared minus pi r squared. And that's not going to be hard at all because you got both of them. S is 8. R is 4, which we didn't need to be told, but we could have. I mean, they did give it to you. I wouldn't need that because if this is 8, then the radius of the circle, which is that, has to be 4, right?
Yeah.
But they'll tell it to you, and they're accurate with it. So 64 minus 16 pi. You don't need that line again. You can calculate right from the plug-in. So we get 64 minus 16 pi, and you get 13.73 about. And it's in square centimeters. So you'll have 6 problems like these ones we've been focused on for the last 15 minutes, where there's something about a circle or a square, something's been cut away. You are to find out what's left with the strategy like I taught you.
Yeah.
Do you see that it's a full circle?
Yeah.
Okay. Everybody okay? Deal. Okay, next problem. Numbers, it's number 16, which is, it's a story problem. Pretty easy. It's talking about a guy that's going to plant a garden. And it's a circular garden. Silly, I would never plant a circular garden. But it's a circular garden, and he wants to plant 5 different varieties, or 7 different varieties, or 8, or 10, could be any of those. Well, could be any number, but it's a whole number. A certain number of varieties of different colored flowers. And he wants to plant the exact same amount of each type, cover the same amount of space in this circular garden. So if he wants to plant 10 different flowers, all in places so that he plants exactly the same area of each, how would you find that out? What area is going to be occupied by each one?
The area of the circle divided by 10.
Yeah, just like that. It's just that easy. Okay, so I'm not going to talk anymore about that one. Find the area of the polygon. 17, 18, and 19 says find the area of the polygon. The first one is a kite. The next one is a regular polygon of some kind, which I'll show you. Well, the next two are 18 and 19. But the first one, number 17, is a kite. You remember how to find the area of a kite? 1/2 D1, D2. 1/2 times the diagonal times the diagonal.
1/2 DD.
Yeah, D1, D2, you know, 2 different diagonals. One thing that you have to remember about a kite, though, and this is all I'm going to say about it, you have to remember this about a kite. When you draw the kite, one of the sticks in the kite, draw that very well. One of the sticks in the kite will be bisected while the other one will not. The one that goes like this, that is not cut in half, but the one that goes like this is, and it's perpendicular. This is equal to this. But this is not equal to this, obviously, or you'd have a parallelogram instead. There is enough information if you understand that this stick is as long as this one for you to find that area using this 1/2 D1, D2. So if I tell you that from here to here is 28 and that this is 4, you're going to take 1/2 8 times 28. See?
Yeah.
There you go. Okay. Next one is some sort of a regular polygon. Let's say that it was a regular 7-sided gon. You want to do that? That's a pretty tough one. It's not that, but it's the process is the similar to it. So what I do is I draw the bottom part of the polygon. Remembering it has 7 sides, I draw a representative triangle right here. This one comes out like this. This is perpendicular. This side's been cut in half. And the information that you get is in this, and they draw a triangle just like this. And they tell you that this is 4, for example, and this is 7. And this is a 7-sided polygon. Remember how before I said that the area of any polygon is, or any regular polygon is 1/2 AP? I don't want to use that one here. I'll tell you why. Because I can find the area of this triangle right now. It's going to be 8 times 7 cut in half. And I happen to know there will be 7 triangles just like that. So I don't want to use this. I've got the apothem, which is the height of that triangle, and I know how long this is. It's going to be 8. So the area of this one triangle is going to be 1/2 of 8 times 7. That's 1/2 of 56, which is 28. And that's the area of this one triangle. And because I know how regular polygons behave, I've got 7 of those out there. I just multiply that by 7. Should be 4 times 496. No? Yeah?
Yeah.
Yeah, okay. 196 square units then. So you have to think a little bit and ask yourself, do I really want to use the 1/2 AP, which covers the whole thing? You would if they gave you maybe the radius length or something like that. But they gave you enough for a base and a height for that representative triangle, and there are 7 of them. The next one is much less given information. Let's pretend again that we were doing a heptagon, which is 7 sides. They won't tell you that. You don't have to know the Greek. They'll tell you how many sides it has. You'll be able to count it. The whole picture's here. But let's pretend this was a heptagon again, 7 sides, and all they give you is this. That's it. And it's 7 sides. And they draw the whole thing for you. Whoever makes this can draw pictures way better than I do. But so they give you a 7-sided figure, we'll say, and it's 12 on a side. That's all you get. And we want the area of that. So I would draw this in my picture, just like I did before. Knowing that this is 6 now instead of that, because the whole thing was 12. And I want to find the area, but I'm going to use area equals 1/2 AP. I need the apothem and the perimeter. The perimeter is easy. I can get the perimeter right now. It's 1/2 something times 84, since 12 times 7 is 84. Do you understand what I'm saying? Okay? Got to find that apothem. I need this. And the only other thing that I can glean from the information I have is that this right here will be 1/7 of 360. This is going to be an ugly one because it has to be a decimal. But we can handle it. So you can your calculator, eats that stuff for breakfast. So I take 360 and divide it by 7 to get the size of this angle, which is right around 51.42. Then I got to cut that in half because I want this angle so I can work the trig on it. And that's 25.714, blah, blah, blah. But you can use about 714, and that should be accurate enough, unless you want to use it all unapproximated. So to find the apothem, I recognize that this angle, which is weird number of degrees, is related to this side that I know, and this side I want to know by tangent again. So I say the tangent of 57.714 is equal to 6 over A. Cross multiply.
Yeah,
25.
What am I doing?
You did say.
Oh yeah, 25. I don't know what I was doing. I don't know where I got 57 from. Is that in here?
It
was
was the
51.
together one.
It was.
Oh, anyway, you're right. This is 25.714. This is 25.714. And it equals 6. And so A will be equal to 6 divided by the tangent of 25.714. Thank you for that. Gosh dang. So in here goes 6 over tangent of 25.714. Then we start calculating. So if you fill in all these gaps just the way it is, we can calculate from there. 0.5, parenthesis, 6 divided by tangent. Close that fraction and close that parenthesis, 84. I get 523.28 about. You getting that?
Yeah.
523.28. And I didn't tell you what this was in. I'll say it was in centimeters again. So this is centimeters squared. Doing okay? Yes, no? You following this?
Mm-hmm.
Here we go. Next set of instructions say find the volume of the solid. Now we're into volumes. And they are 3D pictures that are really nicely drawn. So it's not going to be hard to tell what's going on. The first one is a cylinder. And if you have the formula memorized or written on a cheat sheet, then this will be really easy. Get you a cylinder, something like this. And it tells you this. It shows this and says that that is something like 7 inches. And it shows this, and it tells you that that is something like 10 inches. You got everything you need. Write the formula, though. The volume of this is equal to pi r squared h. That's pi times 7 squared times 10. But you got to know this. Because if you don't know that, you're dead in the water on this. You've got to have these things memorized or written down if you're willing to sacrifice 10 points. So it's pi r squared h, and then we do the math on that. From there, you can calculate it if you want. That's 49 times 10 is 490 pi. You may leave it in that form if you wish, but it is in inches cubed. Now, folks, I haven't mentioned this yet, but all the way through this test, if you give me units, if they're wrong, I'll probably be pretty lenient. I won't take very many points off. But if you could forget to write them down, I may ding you every single problem you forget on. Maybe. That's number 20. Number 21 is just a prism. A rectangular prism, which is a box. And they give you this information. Boy, this is easy peasy. It's probably not worth much. They give you something like this, that this is 8 centimeters, this is 6 centimeters, and this is 12 centimeters. like that. If you want to just, and so you don't risk losing anything, you write down volume is equal to length times width times height. 8 times 6 times 12. 48 times 12, 44 times 4 is 288. Something 56. What is it? 48 times 12.
576.
576. And if this centimeters, it'd be centimeters cubed. Okay, that's number 21. Number 22 looks something like this. This is going to be difficult to draw. I'm not going to try to draw it. It's a hexagonal prism. Meaning that its base is a hexagon. So I'm going to find the area of the hexagon by going like this. And then the distance between the bases, it tells you that also clearly. So on the base of this hexagonal prism, they tell you the length of one of the sides. I'm going to say that it is 6. And they tell you the distance between the bases. It's got top to bottom. It's very nicely drawn. And that height is, we'll say, 22 inches. That's all you get. And I'm sorry that I can't draw it. It just takes forever. And I probably could, but I don't want to. It's a thing like that Toblerone box I showed you. It's got a hexagon for a base. And the distance between them when it stands up tall is 22 inches. You with me there? So the volume in general is going to be, I haven't got my thing to work. I'm going to erase this and put it closer. I'm just going to say the height is 22. And the volume is going to be the base area times the height. And the base area is a polygon, 1/2 AP times the height, which is 22. Do you understand my substitutions? 1/2 AP is the volume of any, is the area of any regular polygon, which is what I have here. So what I need is this, that's the A. I know that's going to be this way. This will be 3 right there because it cuts that in half. And I need the perimeter. Perimeter is easy. 6. There are 6 sides. So the perimeter is 36. You following me or not?
Mm-hmm.
So what I have so far that I can plug in is 1/2. Don't know what A is. Do know what P is. It's 36. And I do know what H is. It's 22. I got to find that A. And because this is a hexagon, there's 2 ways to do it. This, when I drew it out, if I drew that whole thing like this, this has to be 60 degrees because there are 6 triangles that size. Cutting it in half makes this a 30, 60, 90, which is really nice because I have the short leg is 3. I know the apothem will be 3 with 3. Or you can do the trig on it, which would be the sine, the tangent, it's going to be tangent again. Tangent of 30 is equal to 3 over A. A tangent of 30 equals 3. A equals 3 divided by the tangent of 30. If you forgot your 30, 60, 90 relationships. But if you remember them, then going from the short leg to the long leg, which is the apothem, is easy. I will tell you on this problem, this is a hexagon. It's not some other polygon. That is a hexagon. So if you remember this, you'll be all set. So I'm going to grab my calculator and write that. 0.5 times 3 square roots of 3. Keep doing it. Parenthesis 36, parenthesis 22. I get 2057.68. Inches cubed, because we were finding the volume of a Toblerone box. Everybody good with this?
Yeah.
Moving on, we only got 3 to go. Hang in there. The next one has to do with finding the volume of one of the great pyramids in Giza in Africa. So you can expect the volume of it to be enormous. So, gives you a picture of a pyramid. It gives you the actual picture of the pyramid, the actual thing, and then it describes some things to you. The pyramid looks like this. It's got a square base. It's not really great, but we'll go with it. And here's what it says. And I'm going to change the numbers so that you guys have to do the calculation yourself. But it says the Great Pyramid of Cheops, I think is how you say that, is the largest pyramid in the world. It was built around 2500 BC by Khufu or Cheops, a king of ancient Egypt. Okay, none of that has anything to do with the math. Here it comes. The pyramid has a square base of, I'll say, 280 meters on each side. That's what you got here. That's what you got here. Because it's a square base, 280 meters on each side, and a height of 210 meters. That's this distance from here to the center of it, perpendicular, 210. How do you find the volume of a pyramid? That's what they want to know. What's the volume of stone in this whole pyramid? Volume is?
1/3 base times height.
Base area times height. That's why we use a capital B.
Oh.
That's going to be 1/3. Base area is going to be 280 times 280. That's why I'm going to square it. You follow me? The base area is a square, so 280 times 280. I'll just write it once and square it. You with me?
Yeah.
Times the height, which is 210. It's all here. You just got to put it in. $5,488,000. Is that what you're getting?
Yep.
5,488,000 feet cubed. Pretty big. I changed the numbers somewhat, but it's about. These are representative numbers, pretty close. Last two things have to do with the sizes and amount of materials needed to make men's and women's basketballs. I'm going to change the numbers again, so don't expect these to be really representative. It says this: an official men's basketball has a diameter of 11.2 inches. Diameter. Okay. The diameter of the women's basketball is, we'll say, 10.8. So at 11.2 for the men. And this is diameter, inch diameter. For the women, 10 point, did I say 8? 10.8, it doesn't matter. That isn't what they say. I'm just showing you. So that's the information you get. There is no picture. And it says 24, find the difference of the volumes. What does difference mean? Subtract. So we would do the men's minus the women's so that we get a whole number, right? I mean, not a whole number, a positive number. So I would have pi r squared minus, no, volume, what does it say? Find the difference in the volume. So my mistake. 4/3 pi r cubed minus 4/3 pi r cubed. And if we were really using my strategy, which I should do, is the area of a circle minus the area of a circle. It's just that I lied. It's the volume of a sphere minus the volume of a sphere, but they're two different spheres. You just got to keep track. So I would have here 4/3 pi times 11.2 squared minus 4/3 pi, not squared, cubed, pi times 10.8 cubed.
Wouldn't it be smaller than 11.2 because it's the radius?
Yep, thanks for that. 11.2 divided by 2 is 5.6. Is that right? Thank you for that. I would have screwed that up. I would have blown this on the test. This will be 5.4. Thank you for that. Yes, you're going to have to cut it. You're going to have to cut it down. Thanks for reminding me. Like I said, I'm going to not take this class. I'm probably going to be on this test. Okay, so do you know how to put 4/3 in your calculator? It's got to be 4 divided by 3, or use your fraction key or something. I get 76.035. That what you're getting? Maybe I'm wrong. I don't know. That's because I punched it all in at once. I could be wrong. But what I would do if I were you is I'd find that and write it down, and then I'd find that and write it down, and do the subtraction in another step. Try to do it all at once. You may make a mistake. But is anybody getting this? Has anybody tried it?
Yes, I didn't get that, but I might put something not getting that.
Oh, let me see if I got all mine there right. I got that. You got this? Yes. All right. You're wrong.
Okay.
I've redeemed myself from not splitting that, but you got the points on that part. Thanks. All right. And 25, guess what it says? Find the difference in their surface areas. So it's the same dimensions, having to do with the same information. Find the difference in the surface area. So it would be the area or the surface area of one sphere minus the surface area of another sphere. And those formulas pi r squared. Remember, it takes 4 great circles to cover a sphere. So I've got 4 pi times 5.6 squared minus 4 pi times 5.4 squared. $27.65?
Yeah.
Yep. And that's in square inches. Now, the answers won't come out this way, but the process is the same. I changed the dimensions of the men's and women's basketball. They're not that big.
You know the real difference?
Well, no, I can't tell you that. If you want to go look it up tonight, and they agree with what the author of this test did, then yes, you can get it all done. I'm not going to tell you now.
I just wanted to
All I know is the girls' ones are smaller. You can look it up if you want, and then maybe do the problem, and you'll know what the answer is. If the author of this test agrees with what you look up, so don't guarantee it, but it might work.
I just wanted to.
Yeah, okay, all right, yeah, sure, find it out for yourself, that's fine. And that's the end of the test. There are no bonuses, everything is required. And if you took any good notes here, you're gonna know, you have to know the area of a circle, the area of a sector, the area of a triangle, the area of a square, the area of polygons, the area of a kite, the volumes of cylinders, prisms, and polygons, pyramids, and the surface area and volume of spheres. You need to know it all, man. So if you wish to make a cheat sheet, all you can have on it is formulas. Along with the formulas, you can say R equals the radius, or L equals the length, whatever you want. You know, whatever you choose to use for your variables, you can identify what they mean if you want. You cannot have any worked out problems.
It's literally one in
You can draw pictures of the things you wish to find, but you can't have pictures of squares with circles cut out. You have to figure that out for yourself. Based on the thing you have.
When will the test be? Is it tomorrow?
Tomorrow, if we're ready. I don't want to give you any more days. We still got to prepare for a final exam. And I mean, we could postpone it another day because you guys got a whole nother week that the seniors don't.
Yeah.
You want to take tomorrow and just drill and kill each other like a spelling test on these formulas?
Yeah.
Okay, that's fine with me. If I find you're wasting the time, I'm going to be very upset. Remember, I still hold your grades in my fist. Yeah. So don't waste time tomorrow. I can postpone it another day if you'd like. I don't know. I have some. If you want me to mail you the link to this video, put your name up here. He's gonna. Did you need to go? Okay. Listen, this is under, I'm gonna have to trust on this. This is under the condition that when you are done viewing it, you will delete that link.
Okay.
I'll tell you why I don't want the reviews out if you want. I don't want the reviews out because I teach 2 dual credit courses at ISU. And then my teacher, she's a liaison, she's a professor down there, and the head of the department both have my YouTube address. And so they go in there to observe me rather than come up here to observe me in person. You know what I'm saying?
Mm-hmm.
And if they find that I give you this good of a review on geometry, then they think that that might happen with those dual credit courses. I'm in big trouble. That's why I don't want it out there. Okay? So when you're done with the link, get rid of it. It's not that I'm really good at giving reviews, it's that nobody tells you exactly what's gonna be on the test like I do. I don't want them thinking I do that for all of the courses that I teach.
Today? So she literally said, do you remember what I was talking about like a while, like the beginning of this class?
I have this summary if you want. So that you can drill and kill each other with this. Do not bring this with you for your teaching. At least have copied this on your own cheat sheet so that at least you have written them down. Sometime, okay? I'll go make you a copy of this, but this cannot be brought in for your cheat sheet. You cannot use it.
I'm scared now.
It's very good to have
I was like,
So you do not explore it?
I know, but like, I know, like, that's all they thought.
There should be like.
Yeah.
When me and Hannah both started laughing when we thought you were. No, I think.
It's like, that's
I
the-
There are. I see Gordon like this. And they'll randomize one.
My mom actually got
I forgot to stop this. It's over, by the way.